Hi, my name is Zaid, and this is my teammate Yousef. And we originally had the idea of doing aspect-based sentiment analysis on the Yelp restaurant review dataset, but we ended up just sticking to sentiment analysis. And so the motivation behind our project is just looking at a specific restaurant review. There's not much we can benefit from the numerical rating that contributes to the overall restaurant score without actually reading through every single review and getting the feedback. And so aspect-based and sentiment analysis is a way of extracting the most pertinent features from the text of a restaurant review, such as the ambience, the food, the service, and the price, from each of which will be associated with a polarity. In our case, a ternary polarity of positive, neutral, or negative. So you can see our aspects are each being attached with one of these polarities based on um, their associated aspects in the review. And so a couple of ways of actually doing this um, is using named entity recognition, which is a way of finding the most significant like named entities in a given text, as well as using the BERT and Albert deep learning models, which are better suited for actually processing language and inputting that. And bag of words and TF-IDF are also used for extracting the most pertinent features and the most representative words of a given text. However, our approach involved the following.
So what we did first was we vectorized the data using the glove dataset, a pre-trained one. And after that, we added a ternary sentiment label to the dataset, and we used the star rating for that. So 4 stars and above, we attached positive, 3 we attached neutral, and 2 and below we attached negative. That allows us to label the data without doing it manually. Then we pass that into the CNN.
But of course, before that, we did some pre-processing.
Yep. So to pre-process, we started by converting everything to lowercase, removing punctuation. And
Hmm.
after that, we removed all stop words, such as the, and then also lemmatized the language. Then after
And
that, we just tokenized it so that we can pass it easily into the glove dataset, which converts each word into a vector.
hmm and each vector would be like associated with the meaning of each word. And so what we pass this into is our CNN model, which involves two convolutional layers to begin with, and between them are the nonlinearity layer, the batch norm and dropout layers, which help reduce overfitting. And after that, we pass into average pooling layer, which also just averages out blocks of the matrix in order to avoid um, overfitting from uh, anomalies or far off values in the data. And we pass those into fully connected layers.
So we ended up using k-fold cross validation on our model. We had a 40-40-20 split, um, with the two first sets being training and the 20% being validation.
Mhm,
Overall, we were able to achieve 81.6% accuracy.
And just for reference, we use the cross entropy loss function just to be able to
Mhm.
get the loss with because of our model being a classification model. And so we can actually demonstrate how our model functions. Over here, we can input like a sample text. So this one says, I enjoyed the spacious, comfy setting of the building, and the servers were nice, and the service was quick, but the food sucked. So this is detected as an overall positive rating. And so as we can see here, after some of the pre-processing takes place, the sentiment is predicted as a positive text. Then when we move to something like, bro, this place sucks, literal garbage, rather die than come back here. It turns out to be, believe it or not, it turns out to be negative. But when it comes to something a bit more ambiguous, like the food was good, but it gave people diarrhea. So that one is an ambiguous one, and we can see that this actually gives the predicted sentiment neutral. And yeah, that concludes our demo. Thank you for listening and watching.